Hi everyone, welcome to my channel, Tutorlini Test Prep. Today I'll be providing a full walkthrough of the digital PSAT NMSQT Math Practice Test number 3. The digital PSAT NMSQT is a preliminary SAT exam often taken by American students in the 10th or 11th grade. The exam is incredibly similar to the SAT, so you should watch this video even if you are only taking the SAT. I highly recommend you complete the exam yourself before watching this video. You can use the chapters in the description to quickly jump between the 3 modules. Let's get started with Module 1. Okay, this is the beginning of Module 1, Question 1. So we want to find the y-intercept. The y-intercept is where the graph touches the y-axis. I'm seeing that happens right here. They actually put a little dot there. That's very nice. So the coordinates of that point are 0, 2. So the answer to this problem is 2. Okay, question 2. So for this one, we have to do some words to math. So I'm going to pick out some of the keywords. I'm seeing this word acceleration. Why don't we call that A for acceleration? Then I'm seeing the word is. That means equals. And then it says the change in the object's speed divided by the time. So why don't I call the change in the object's speed, I don't know, why don't we call that S? And then the time, we could call that T. And now we just need to put in the key information. So they said the car's speed changes by 58. So we're going to put that in here. And then it says 8 seconds have passed. So that guy, remember seconds, that's the unit of the time right here. So we're going to put that in for the time. And we get acceleration equals 58 over 8. And now we just got to jump to the calculator real quick. That is 7.25. And that is looking a lot like choice B. Okay, question 3. So the problem says that x is equal to 1. So we're just going to go into this function here and replace all the x's with 1. I just highlighted them in yellow. So we get f of 1 is equal to 9 times 1 plus 21. Well, 9 times 1 is just 9. And then 9 plus 21 is 30. So that's the answer. We can also evaluate functions on Desmos. Let's go do that. Okay, so I just typed in the function exactly as it's written. You kind of have 2 options here. We could just plot x equals 1 and then go where it meets. And you can see that happens when y is 30. That's the value of the function, the y value. However, guys, much easier, especially when you get really wacky graphs and plotting these vertical lines, is whenever you have a function and an x value, you just use function notation. So if I just type in f of 1, it also tells me 30. Okay, question 4. I actually have a short on this, guys. It's called vertical angles plus linear pairs. Definitely go watch that. I'm just going to assume you've already seen that. So these lines are parallel, but you actually don't need to know that at all to get the answer. So these 2 angles here, they form a straight line. That is called a linear pair. The thing about linear pairs is that the angles are supplementary. They add up to 180 degrees. So we're going to do x plus 48 equals 180. We subtract 48 from both sides. And we get x is equal to 132. And that gives us choice C. Okay, question 5. This might be the silliest SAT question I've ever seen. So they're just asking us for x, and one of the equations can be very quickly solved for x. All we got to do is divide both sides by 8, and we get x equals 2. And that's the answer. I have no idea why they gave us that second equation. We could check it on Desmos too. Let's go do that. Okay, so all I did was type in these two equations. Now, to solve a system, we see where the two colors meet. So we're looking where blue and red meet. So I click here. That's right here. I like to export the point and label it so that I don't forget what the numbers are. I can clearly see that x is 2 and y is -3. Since they asked us for x, we put 2. Okay, question 6. I cover this in my Ottocento number 4 on factoring. Definitely go watch that. If you want the abridged version, I have a short called Factoring Out the GCF. That's what this is testing us on, factoring out the GCF. So first we look at the numbers in front, 2 and 12. The numerical GCF, greatest common factor, the biggest number that goes into both those is 2. So we're going to plot a 2. And then we see if they both share any variables. Well, they both share an x. What's the highest power of x that they both have? Well, the first one has 2, and the second one has 1. So they share the lower number of that. They share at least 1x. So we're going to pull out 2x. And then to figure out what's left on the inside, it's just kind of like division. We divide both these by 2x. 2x squared divided by 2x is x. And then 12x divided by 2x is +6. So we're going to put x plus 6. And lo and behold, that is one of the choices, choice A. And that is our answer. We can also go do this one on Desmos, so let's go do that. Okay, so I just typed all these choices in. And what I'm going to do is the expression in the question is the first thing. We're going to keep that. But we're going to unhighlight everything else. And now you can just do process elimination. So for it to be equivalent, they have to look exactly the same. It must look exactly the same as the red. So you just toggle them on and off. Okay, that doesn't look right. It's not the same. Choice C, not the same. Choice B, not the same. Choice A, oh, perfectly replaces the red. That means it has infinitely many solutions. And that means it is equivalent. So A must be the answer. Okay, question 7. I go over this in great detail, guys, in my Ottocento number 2 on unit conversions. Definitely go check that out. I'm going to assume you've already watched that. Okay, so they want us to convert between seconds and minutes, so that's just one we need to know. So I'm going to write that down off to the side. 60 seconds equals 1 minute. And then we're going to start off with 37 feet per second. And we actually don't need to convert the feet, so that's convenient. But we do need to convert the seconds. So we want the units to cancel. So I'm going to put 60 seconds on top and 1 minute on the bottom. If the units are on opposite sides, the matching units are on opposite sides of the division sign, then they cancel. See how those guys are on opposite sides of the division sign, so we're good. So now I have units of feet. The division sign is per minute, feet per minute, and that's what the question wanted, feet per minute. So we're good. So now we're just going to, quote unquote, like a gymnast, stick the landing, okay? So I would always just type it in exactly as you have it written so you don't make a mistake. And I am getting 2,220, which is choice D. Okay, question 8. I have a short on this, guys. It's called parallel plus perpendicular slopes. The concept here is that perpendicular lines, the slopes are opposite reciprocals. So you flip it and multiply by -1, change the sign. Flip it and change the sign. So y equals mx plus b. So the slope for this first line is 2. So if you write 2 as a fraction, that's the same as like 2 divided by 1. So if you flip that, you get 1/2. But then it's opposite reciprocal, so you have to multiply by -1 as well, so it's going to become negative. So the perpendicular slope is -1/2. You really got to know that, but we also actually can like kind of visually confirm that it's right by using Desmos, so let's go do that. Okay, so I typed in the first line, and then I just typed in the second line as y equals mx plus b. The b doesn't matter, we're just checking the slopes here. You could put anything for the b. And I'm just going to change the slopes, and let's see if we can. We might not be able to, but let's see if we can visually spot. So -1/7 is like, that looks pretty close, but it should look like a cross, you know, it should look like a T. So that's no good. Let's try -1/5. That's closer. And let's try negative 1/3. That's 1/3. That's really close. But let's look at negative 1/2. Tough to tell, guys. That's why they made these trap answers very close together. But you can see that negative 1/2 was the only one that formed a perfect T, which means it's perpendicular. Okay, question 9. This question, just doing a quick glance at the choices, they want us to distribute. So we're going to distribute. So we're going to do 4xy times 2x squared. Okay, 4 times 2 is 8. X times x squared, that's x cubed. And then y times, there's no y, so y times 1 is just y. And then we're going to come over here and we're going to do the second term. So 4xy times positive 6y. 4 times 6 is 24, so 24. And then x times, well, there's no x, so just 1x. And then y times y is 2y, so y squared. Okay, that is looking exactly like choice D, which is the answer. We can also do this one entirely on Desmos, so let's go do that. Okay, guys, so I just typed in everything. When you're plotting with x's and y's, you could plug in numbers if you want, but I'm just going to plot it. I think that's easier. When you're plotting with x's and y's, you do have to set it equal to a number. Make sure you pick a number that works for all of them. So I set them all equal to 1. It's usually the first number I try, and you'll see this works out pretty well. So we're going to go through and just do process elimination, just like we did before. Choice A, doesn't perfectly replace, no good. Choice B, doesn't perfectly replace, no good. Choice C, doesn't perfectly replace, no good. And choice D, oh, that is looking good. It perfectly replaces the original expression. So that means it has infinitely many solutions, and that means it is equivalent. Okay, question 10. So I really don't think the by hand and Desmos way methods are that different. So why don't we just go straight to Desmos? So I typed the function in, and I noticed in the choices that all the x values are -1, 0, and 1. So why don't I just evaluate those on here? So h of -1, h of 0, and h of 1. And I am getting 1, 6, and 11 as the y values, and that is perfectly matching choice B. If you didn't know, guys, a little trick you can do is if you make a table, you can replace the y1 with the function of x1. So I just did h of x1. And if you go and put in just any numbers for the x's, you could like actually recreate the table, which is kind of neat. That really helps me a little bit on some harder questions. So, okay, question 11. I pulled this up from my flashcard, my short on squares. So the perimeter of a square is 4s, and the area of a square is s squared. I just wrote the 4 times 85 is 340. Let's just pretend, maybe make it a little bit harder. I don't know why they wrote it as 4 times 85. It maybe to give you a hint, but I don't know. They might not always do that, so plan for the worst. So the perimeter is equal to 4s. So 340 is equal to 4s. I divide both sides by 4. And I get s is equal to 85. That's the side length. So the square has 85s going all around where those s's are. And that's what they're asking us for, so that's the answer. But just keep in mind, another follow-up question they might ask you is the area. So for this one, you would square 85 and get like 7,225, something like that. So make sure you know how to work with those formulas very quickly. Okay, question 12. So I go over percents. You could go to my formula sheets video and download my percents formula sheet, but I go over it in great detail in my 2 Otocentos, number 1 and number 26, and in tons and tons and tons of shorts. So I have like, 7 shorts on percents. Anyway, this one's not so bad. The multiplier very clearly is 0.67. So now we just need to make sure we convert it using what we're supposed to. So this question, very important keyword. Pay attention, guys. Look where I'm putting the yellow. Percentage of. So to find the percent of, and this is in the formula sheet, the percentage divided by 100 is equal to the multiplier. So the multiplier is 0.67. So to change it to a percent, we need to times both sides by 100. So 0.67 times 100 is 67%. and that is choice C. So for percentage of, to go from the percent to the multiplier, we divide by 100, but to go from the multiplier to the percent, we do the opposite. We multiply by 100. Okay, question 13. So I'm noticing here, to do this by hand, that those two guys have the same magnitude, but are opposite in sign. Like they're both 6, but one of them's 6, one of them's -6. So to get rid of those two terms, we can use elimination, and we can add them, and they will go away, because 6 plus -6 is 0. So 6x plus -6x, that just goes away. So I'll like cross that out. And then 6y plus 2y, that's 8y. And then 50 plus 6 is 56. We can now divide both sides by 8, and we get y equals 7. And that's what they're asking us for, so we don't need to go back and plug it in. So the answer is C. And now we can go and do it on Desmos, so let's go do that. Okay, so I typed these equations in for a system. We see where the two colors meet. I'm going to export it and click label. And you can see that x is, let's just see what that is real quick. That's 4/3. And y is 7. We didn't put 4/3 though, because they were asking us for y, so we put 7. Okay, question 14. I go over this in great detail on my auto tutorial number 20, probability plus two-way tables. Please go watch that if you haven't already. Okay, so we want to find the probability of selecting a tile that is labeled with a diamond. So probability is desired over total. So the ones that are labeled with a diamond are 6 of them. So that's the desired, that's 6. And then the total is what they told us at the beginning, 40 tiles. And you don't have to, but if I were you, I would simplify that. So I simplified that on my calculator, and I got 3/20. The decimal is also pretty good. You could put 0.15, but I always prefer to just put the fraction if it's a pretty nice fraction. So 3/20 or 0.15 is the answer. Okay, question 15. I don't think I have a separate video on interpreting slope and y-intercept, but I do have a little tidbit in my free formula sheet. So go to that video and you can download the lines formula sheet, and it's on there at the end. So anyway, I just rewrote the equation off to the side. It's testing us on y equals mx plus b, but I rewrote it to make it more clear. So it's -148x plus 500. Make sure the negative, it stays with that 148. And it's asking us about the 500. So it wants us to interpret that y-intercept. So the y-intercept is the y value when x equals 0. So what this is saying is y equals 500. What does the problem say y is? It says meters from the machine. So meters from the location, something like that. When x equals 0, what does it say? X hours, so hours after the start. You can also just look for keywords, but I like to interpret it literally. That way I have some idea of what the answer is before I even look at the choices, so I don't fall for a trap answer. Okay, so 500 meters from the location when x equals 0 are at the beginning. So I'm seeing some keywords here. The machine's distance in meters from the designated location, which is 500. At the start of the experiment. That's an in-context way of saying x equals 0. This is saying y when x equals 0. Looking like C is the answer. Give me a second. I'm going to figure out what A, B, and D are just for the sake of the video. Okay, so just so we're clear, there was a really key word that's in that formula sheet. We're looking for y-intercept initial or start. This was the only one with any of the keywords for y-intercept, so you should be thinking it's C right away, even if you were a little confused. But just for the sake of the video, I went through and figured out what A, B, and D were. So D, it's the distance traveled per hour. So that's like the absolute value of the slope. So it's traveling 148 meters in 1 hour. B is describing the slope. Velocity can be negative, so it's negative 148 meters per hour. That's how fast the machine is moving, but like it's negative because velocity can be negative. If you take in physics class, that will hopefully make sense. And A is describing the x-intercept, which you would have to figure out. So don't worry about that really for this question. But it was like 3.3783. So in about like 3.4 hours, it will reach the desired location. Okay, question 16. I do see a square, and that makes me think I want to use similar scale factors, which is a different video I have. But because one of them's a rectangle, these two shapes actually aren't similar. They don't say they're similar, and they would have to both be squares for it to be similar. So we actually can't use scale factors. We're going to have to use what's called scaling variables. I actually just made a video on this, Oda number 34, scaling variables. I'm just going to assume you've already watched that. Go check that out. So the question says the length of rectangle R is 7 times the length of a side of square S. So why don't I call the length of a side of square S, why don't I call all the sides, they're all going to be the same, why don't I call them all X? And the length of rectangle R is going to be 7 times that. So we're going to do times 7. So that will be 7x. And then it says the width of rectangle R is 4 times the side of square S. So why don't we call that 4x. And it says the area is 1792. And we can also do the area, which is length times width. So 7 times 4, that's 28. And then x times x, that's x squared. So 28x squared. Again, guys, that's just 7x times 4x. And that's equal to the area, which is 1792. So now I divide both sides by 28. I get x squared equals 64. And now I take the square root of both sides. And that gives me x equals 8. So that means that these guys are all 8 because x is 8. And then the dimensions of the rectangle is 8 times 7, which is 56. And 4 times 8, which is 32. They want us to find the length of the side of the square, and that is 8, which is choice A. Just to summarize here, guys, the area of the square would be 8 times 8, which is 64. And we can see that this area is 28 times as big. You can imagine where that came from. That came from the 7 and the 4. I go over that in the scaling variables video. Definitely go watch that if you want to learn more about this topic. Okay, question 17. I go over this in great detail, guys, in my Oda channel number 13 on basic quadratics. Definitely go check that out. And formulas for quadratics are actually in very concise detail in my free formula sheet. So go to my free formula sheet video and download that for sure. The quadratics one is super helpful. All right, so this is factored form. Factored form tells us the x-intercepts. So we're going to set y equal to 0. And then solve each of these little tiny equations using the zero product property. So x minus 5 equals 0, x minus 33 equals 0. And we add 5 to both sides. We get x equals 5 for one of the x-intercepts. And then we add 33 to both sides, and we get 33 for the other x-intercept. And now we use the midpoint or roots equation, which I go over in that video, h equals s plus t over 2. That is the x value of the vertex, which is where the minimum will be. So that keyword, if you see minimum or maximum, it's talking about the vertex. And what value of x? That's h. So we do h equals 5 plus 33 divided by 2. That's 38 divided by 2, which gives us an h of 19. And that is the answer, choice C. We can also do this one entirely on Desmos, so let's go do that. Okay, so I just typed this function in, and now we're gonna like zoom out until we see the vertex, and then I like to zoom back in like close to it. And if we just click on the vertex, it'll tell us. I like to label it. So we get 19 comma negative 196 because the question said for what value of x, then we put 19, which is the x coordinate. If it just said, what is the minimum of f of x, and it didn't mention x at all, then we would put negative 196, which wasn't an option, but this could be student producer's response. So make sure you pay attention to that wording. You don't accidentally put the x value when you meant the y value. Happens all the time. Okay, question 18. I cover some problems like this in the Ottocento number 24 basic exponentials. Definitely go check that video out. So there's a lot of moving parts in this one. It's a lot of words. First of all, do you notice how it mentions each year the red maple tree's height, which is what they're asking us about, by the way. It says increase. So I think right away, I don't think they're trying to trick us there. I would pretty safely assume A and C are out because those are decreasing. There's no way that could be it. So now the question is it increasing at a constant rate of change, constant ROC, then that would be linear. And if it's not constant rate of change, then it's exponential. So we need to do some very careful wording. So it says, words to math. So it says 32% less than the maple tree's height increase in the same year. Well, if you look at the silver maple, that is just a constant 2.3 feet. It's always 2.3 feet, the increase. So we just need to do 32% less than 2.3, and then we'll have figured out what the increase is for the red maple. So we could go do that really quick. So 32% decrease, that's 1 minus 32 over 100. So that's a multiplier of 0.68. So we're going to do 0.68 times 2.3. So the red maple, that like sentence that I highlighted a bunch, is basically saying that the red maple increases by 1.564 feet each year. So 1.564 is a number. That means it's a constant. So it's going up at a constant rate of change. So this is increasing linear. It's basically, let's say it's 100 feet. We're doing each year plus 1.564, plus 1.564, plus 1.564. That is linear. If that amount wasn't staying the same, 1.564, 1.564, 1.564, it would be different. I think, how about this? I'll go make a little picture. I'll pretend they both start at like 100 feet and show you what's happening. Okay, guys, so I made a little story for like, I don't know, the first couple of years. I just did the first 3 years. It does go on for 5 years, but I just picked both of them at an arbitrary starting height of 100 feet. And you see I made S, the silver maple, going up by 2.3. So he goes 102.3, 104.6, 106.9. And then in a roundabout way, they told us that the red maple is going up by 1.564. So I did the math there. And let's go look at that. We click at this little magnifying glass. And maybe don't do that because it alters the window, but you can kind of see that these are going up at a constant amount when x goes up by 1. They kind of look like lines, right? Like if I go and regress these, they form perfectly straight lines. So that means it's linear. Okay, question 19. We could clear denominators here, but since we have a fraction equal to a fraction, why don't we just cross multiply? So the yellow diagonal, I get 8 times x minus 19. And the blue diagonal, I get 24 times x minus 19. And you could distribute, but I'm noticing that these guys are the same. So why don't I just like combine the like terms? And to do that, I'm going to subtract 8 x minus 19s from both sides. So let's do that. You can also solve it via distribution. You should get the same answer. So this will go away. And we get 0 equals 24 minus 8 is 16. Now I divide both sides by 16. You could distribute, but again, this seems faster. 0 divided by a number works out pretty nice because that's just 0, right? And then 16 divided by 16, that's 1. And since we're multiplying, it goes away. And now we add 19 to both sides, and we get x equals 19. But be careful, the question wants us to find x plus 19. So x plus 19 is really 19 plus 19, which is 38. So that is the answer, choice D. Got to make sure you don't read it too fast. We can also do this entirely on Desmos, so let's go do that. Okay, so you can do this using regression. Just be careful with that, because if the equation has more than one solution, you might miss one of them if you're using regression, or maybe the regression just won't work. So just be careful with that. I always like to do y equals left-hand side, y equals right-hand side. And so I can be certain, okay, I'm looking, the blue and red, they're straight lines. They're only going to meet in one spot, and it looks like it's over here. And I click on that, and I am getting 19, 0. Remember, the y we just made up, it's meaningless. So x is 19, but again, you got to add that 19 to it because it says x plus 19, and you get 38. So you have a bunch of different options to do this one. Desmos might be faster though. Okay, question 20. I go over this in great detail, guys, in my Otocento number 11 on SOHCAHTOA. You can also get my free formula sheet on trigonometry. That'll help with this problem. And I think I have a short on Pythagorean theorem if that gives you trouble. So definitely check all those out. This question is talking about angle L. So that's why I highlighted angle L. And we're going to very carefully identify the HOA, hypotenuse, opposite, adjacent. So across from the right angle, that's the hypotenuse. So I'll put hype. Across from the angle of interest, the one we colored, is the opposite. And then the last angle is the adjacent. So this question is talking about tangent. So we're going to do tangent of angle L is equal to, if we look in the question, opposite or adjacent, remember TOA. So we need to do opposite over adjacent. So the opposite is JK. So we're going to put JK. And then the adjacent is LK. So I'll put LK. And they said that was equal to 3 over 4. It says that in the question. So next to JK, I'm going to put 3. And next to LK, I'm going to put 4. But we don't know what those are. It's just a ratio. So we have to introduce a dummy variable. That's in my formula sheet on this. So I'm going to just pick any letter I want. How about x? So we're going to call this 3x and then 4x. We unfortunately can't find what x is by looking at those sides because we don't know either of those sides. However, we can use the Pythagorean theorem, 3 and 4, and find what the third side is. Hopefully that one you just know off the top of your head. But we do a squared plus b squared equals c squared. I called the hypotenuse x. So 3 squared plus 4 squared equals x squared. You do that out, you should get x is equal to 5. And like not the x in the problem, like that third side is 5. So we're going to label this guy 5, and then whatever your dummy variable is, x. You can use whatever letter you want. If all the x's are confusing, use a different letter. Like I like to use k or like b or something. Anyway, so we've got 3x, 4x, and 5x. So now we can see that 5x is equal to 95. We divide both sides by 5. And we get 19 for x. But remember, that's not the answer. We got to find the other side. So those other sides are 3 times 19 and 4 times 19. Okay, so for 3x, for 3 times 19, I am getting 57. And then for 4x, I am getting 76. So now you can triple check it. You could be like, okay, if I do 57 squared plus 76 squared, do I get 95 squared? And you can check to make sure the tangent is 3/4. Actually, why don't we go and do that? So let's triple check that we did all this right before we lock in our answer. So 57 squared plus 76 squared, that should give me 95 squared. And indeed it does. And if we do tangent, we do opposite over adjacent, 57 over 76, we should get 3/4, which we do. So the question wanted us to find, I don't even remember, JK. So JK was 57, and that is choice C. Okay, question 21. This is going to be really hard to explain, guys, because we pretty much just have to look at it. So what I did was I colored each curve. I made one of the lines yellow, one of the lines green, and one of the lines blue. I hope that makes it a little bit easier. So anyway, we have a system of 3 equations. So we need to see where all 3 meet. So try to just look with your mind's eye, where does yellow, green, and blue all exist at the same time? And the only place I'm seeing is at 0, 3, like right there. So they just meet at 1 point. So there's only one solution. The answer is A. I actually think because one of them's lines, really the only options are 0 solution or 1 solution. Maybe 2 is an option, but I don't think it's going to be 3 or 4. Again, I wouldn't try to memorize any kind of rule for like a linear quadratic system. That's like incredibly rare question. I would just try to look with your mind's eye really hard on this digital exam. You could maybe copy the drawing onto your paper, and that might help. I don't know. Okay, question 22. I definitely think this one's going to be easier to do just straight on Desmos because we're talking about graphing inequalities. That's very hard to do in your head. But let's go do that. Okay, guys, so I typed in these 2 inequalities, and now we're going to zoom out and see where they kind of intersect. So let's go do that. Looks like they intersect up here. I'm going to zoom in a little bit. And I'm going to click on where they meet, and then I'm going to export it and label that, because that's always important whenever you have a system, the point of intersection. Okay, so do you see how we have these only one pizza slice, this top left pizza slice with both colors? That top left pizza slice is the solution set. Both colors must be present for it to be part of the solution set. So when I go put it on the board, I'm going to draw it, but just with that pizza slice that we care about. Let's go back to the whiteboard. Okay, guys, so it is asking us about X. So I'm looking at this, the X values for all solutions, and remember the X of that point of intersection was -4. So I'm right of way thinking 6 and the 2 6 choices are just out. It has nothing to do with 6. So the question becomes, we're just looking at the X value. So that solution set is going up and to the left. So if we move away from this point into the solution set, you see how we're going left and up. So that means the X's are going left, so they're getting smaller. And the Y's are going up. That's positive Y direction, so they're getting bigger. So since the X's are getting smaller, we're going to go with X is less than -4. Again, just think about it. If I picked like X is 0, that's going to be like over here. That's not in the solution set. So hopefully that makes sense. One last thing, and you guys don't need to know this at all, but I actually figured out how to make a picture of just the solution set so that we could look at it, just to drive this home. You don't need to know how to do this at all. I just want to show you guys, you see, look, if I put X is greater than 4, the solution set, those X values are nowhere near there, right? Almost, actually none of them are captured, right? But if I put X is less than -4, you'll see that all of the green area is fully encapsulated within the purple. That means all those X values are indeed smaller than -4. And again, as we talked about, 6 has nothing to do with the problem, so those choices should have just been thrown out at the beginning. Okay, this is the beginning of Module 2A, Question 1. If you would like to skip to Module 2B, you can see the timestamps at the bottom of the description. All right, so for this question, it wants us to find the 4-day period where the number of hours of direct sunlight was the greatest, So we look here, the hours of direct sunlight is the y-axis, so the greatest y value is the highest point on the graph. So the highest point on the graph is right there at the very top, which is at day 3. So the answer is C, day 3. Okay, question 2. So the key concept here, guys, is that when x is 0, we're looking for a y-intercept, and when y is 0, we're looking for an x-intercept. So here I see that y is 0, so that means we're looking for an x-intercept. So I'm looking along the x-axis to see where the graph touches that, and it seems to happen right here at this point, 5, 0. Question wants the x-coordinate, so we are going with 5, as you can see there. Okay, question 3. For this one, I'm noticing that in the table, all the x values are 27. When x is equal to a number all the time, that means the graph is a vertical line. And when y is equal to a number all the time, that means the graph is a horizontal line. You see y is changing, so it's not constant, so it's actually not a horizontal line. It's that first one, a vertical line, and it's going to be x equals 27. If you were a little confused by this, you could go and graph it on Desmos. So let's go do that. Okay, so first things first, I'm going to make a table and then just type these points in. So 27.1, 27.2, and 27.3. And then if you want, you can zoom fit. And you could see it's going straight up and down, vertical line, right? But now you could go and like type in the choices. So x equals -27, that's nowhere near there. But if we do x equals 27, we see it goes straight through. And if you typed in C and D, it wouldn't go through those points. It's gotta be choice B. Okay, question 4. First thing I'm gonna do to solve this equation is subtract 70 from both sides. This guy goes away and we get negative W equals 30 minus 70 is negative 40. And now we're going to multiply both sides by -1. And we get W equals 40, which is choice D. We can also do this entirely on Desmos, so let's go do that. So for really straightforward equations, you can get away with just typing it in left to right. You don't have to break it up. So I just used an X instead of W. I'm going to zoom out. And then I see a vertical line at 40, so that is the solution. Okay, question 5. I have a great video on this, guys. It's my short called Absolute Value Equations. I'm just going to assume you've already watched that. Go check that out before watching this. All right, so we can't distribute across an absolute value, so we need to get that absolute value by itself. And the way we're going to do that is we're going to take that 2, and we're going to divide both sides by 2, since the opposite of multiplication is division. So if we divide both sides by 2, we get absolute value of x is equal to 23. Now we've got an absolute value isolated, so we look at the number, the constant on the other side, and we determine if it's positive, 0, or negative. It's positive, so that means there are 2 solutions. And the 2 solutions come from taking the thing inside the absolute value, in this case x, setting it equal to positive 23, and then also setting it equal to the negative version of that number, so negative 23. And fortunately, those aren't really equations. That's just it. We're done. So those are the 2 solutions. And since A is the only one that shows up, we're going to go with A. We can also solve this equation entirely on Desmos. Let's go do that. Okay, so if you go and type this equation in to Desmos, it'll plot the vertical lines, but it won't let you click on them, so it won't tell you what the solutions are. So that's just because absolute values, lots of things make graphing equations harder for Desmos. So whenever you're stuck, you always want to do y equals left-hand side, y equals right-hand side. So we're going to do y equals the left-hand side and y equals the right-hand side, and we're just going to treat it like a system. And instead of looking for the x-intercepts, we're looking where the 2 colors meet. So they meet here and they meet here. And the y values are just made up. They don't really mean anything. I just made up y myself, right? So all we care about is those x values. And you can see the x values and thus the solutions are negative 23 and 23. that's what we got doing it by hand. So it seems like we did a good job. Okay, question 6. I have a great video on this, guys. It's my Ottocento number 2 on unit conversions. Definitely go check that out. It's one of my most important lessons. Okay, so it's asking us about the remaining pages. So 160 minus 120 is 40. So she has 40 pages. And it's 1 page every minute. That's like a rate. But if you want, you could just treat it as like 1 page equals 1 minute. Again, let's pretend it's a harder one, guys. So we've got on the bottom, I'm going to put the unit to cancel. So the pages, I go over that in the video that I mentioned. And then on the top, I'm going to put 1 minute. And see now, the pages is on opposite sides of the division sign, so we can cancel it. So this looks good. So we're left with just minutes, which is what they wanted. And we're basically just doing 40 times 1, which is just 40. Another way to approach this one, guys, is to treat it like distance equals rate times time, but like instead of distance, you're doing the number of pages. So like that's where the 40 pages would go. Hope this helps. Okay, question 7. So this is a basic exponentials question. Go check out my Ottocento number 24 on basic exponentials. You're also going to want to watch my many percents videos if you don't really know a lot about percents. Okay, so the A is the initial or starting Y value. So in this problem, it's the initial amount. So see how it says a mass of 28 grams, and then this really important keyword started that's kind of telling us like initial at the beginning. So we know the A is going to be 28. And unfortunately, that doesn't really narrow it down because they all have 28s in front. So we have to look at the second sentence. So we are looking for, it says each week, so that means X is going up by 1. Classic basic exponential stuff. The remaining mass of the sample was approximately 70% of. So that is going to go here. And now we just need to calculate what the heck that is. So so percent ofs, we take the percent and we divide by 100. So that's 0.7. So that is the multiplier. And the answer is choice B, 28 times 0.7 to the X. I just want to highlight here that if you didn't read it carefully, there's some trap answers here. So if you thought it said 70% less, that would be this, which is 0.3. So lots of people who maybe read it too fast and thought it says 70% less or fewer would have picked A. And then lots of people who thought maybe it said 70% more, they would have picked D. You got to be really careful. Again, the keyword here, guys, you see it says 70% of, and we calculate those multipliers. All you do is divide by 100, change it to a decimal. Okay, question 8. So I go over this in great detail, guys, my Ottocento number 4 on factoring. This is called the zero product property. We got a bunch of stuff multiplied together. And when those things are, when that whole thing is set equal to 0, we take those factors and we set them equal to 0, zero product property. So we're going to do X minus 245 equals 0. And X plus 246 equals 0. And I add 245 to both sides, and I get X equals 245. And I subtract 246 from both sides, and I get negative 246. So it says, what is a solution? So I guess I can just pick one, so I'll just put 245, but I'm pretty sure you also could put negative 246. Either would be fine, just don't put both. And we could also do this on Desmos. Let's go do that. Okay, so I typed this equation in. Now I'm just going to zoom out. Hopefully it lets me click on them. It's a quadratic equation, so it should. Okay, so I'm getting 245, and I'm getting negative 246. So we get the same thing. Seems like we did a good job. Okay, question 9. This is, I think, a distance equals rate times time problem, d equals RT. So it sounds like the time is 4 seconds. So that's t is equal to 4. And then this thing with the word per in it, that is a rate. So the rate is 20. So that means the distance for how many meters is, the rate is 20 meters per second times 4 seconds. I always like to check the units, make sure they go away, give me what I want. And so we just do 20 times 4, which is 80. So the answer to this one is 80 meters. Okay, question 10. We're looking for a system with a solution of 5, 5. So we're looking for whichever one meets at 5, 5. The two lines need to meet at 5, 5. Well, this one I think has no solution. C is just no solution, so they don't meet at all. So it definitely can't be C. And now we're going to go and look at where they meet on all these. So let's see here. This guy meets here, and this guy meets here. And this is like, I don't know, 2, like 2.5 or something. I don't know. It's the point is it's not 5, so he's out. This is 5, I think, 0. So he's out. So it's got to be D, but let's make sure. This one here, again, this is looking like 5 and 5. So that is 5, 5. So the answer is D. Looks like we did a good job. Okay, question 11. So the snowfall is between 4 and 9. So to find between as a compound inequality, we are either going to do this: 4 is less than or equal to S is less than or equal to 9, or 4 is less than S is less than 9, or some combination of having equals or not. And the reason we use equals is because these are like maximums and minimums. So this is like the minimum, and this is the maximum, and just in context. And with inequalities, you have a maximum or a minimum, that value is included. So like the lowest recorded value of 4, it can be equal to 4. So that's why we put the equal to. So it is not that, and you'll notice that's not even a choice anyway. So it's got to be this one, which is choice B. That highest recorded level 9, it could be equal to 9. So we have to put an equal to next to 9. There was at least one day with a snowfall of 9 inches. That's what that sentence is telling us. Now, if you weren't sure, you actually could go and graph all these. So let's go do that. Okay, so I got choice A, B, C, D typed in. Only difference is you got to use X to graph it rather than S. You got to use X to graph an inequality, one variable inequality. So X is less than or equal to 4. Well, it's like I got numbers over here like -10, -9. You can't have negative snowfall, so that doesn't make any sense. And if we look at this one, we can see that's like 13 and bigger. And I'm seeing numbers like 20, 40, 60, all the way up to like 1 million. We're probably not going to get 1 million inches of snowfall. So that doesn't really make any sense either. Let's look at the other wrong choice, choice A. And you could see here that this is between 5 and 13. And the lowest recorded snowfall, like 4, for example, and 9, those aren't even in. 9 is, but 4 isn't even in the solution set. So that can't be right. We have to be able to hit 4. So let's look at choice B. Okay, so we got a smallest value of 4, highest value of 9, and then everything in between, every single number in between 4 and 9 is a possible value for snowfall. Okay, question 12. I go over this in great detail in my auto-transfer number 1%. I also have a short on percent of, and you can download my free formula sheet. Go into the free formula sheet video on percents. Anyway, so 10% of 640, so percent of means to change the percent we divide by 100 and change the of to multiplication. So 10 divided by 100 times 640. 10 divided by 100 is 0.1. And now we just do 0.1 times 640, which is 64. We can also do this on Desmos, so let's go do that. So we can type in what we just came up with at the beginning, or you can also use the percent of button. So if you didn't know, you could just press 10 and then press the percent key. And that's really good for numerical percent of questions. We get the same thing, 64. Okay, question 13. You're definitely going to want to check out my auto tutorial number 9 on basic statistics. In particular, you're going to pay attention to the part of the lecture that talks about outliers. That's what this question is testing us on. So we got a group of 10 storage containers. So there's 10 numbers there. And then so there's really 4 listed, but there's 6 we don't know. So I put like 6 question marks to represent those. And the mean is 3245. It tells us that. And one of these containers is going to be removed. One of the 4, not the 6 on the right. One of these 4 is going to be removed. So it's either this one, or this one, or this one. And we want to know which one has the largest difference between the mean of the original and the new group. Which one will have the largest effect? So I go over this in the video. The farther away a point is from the mean, the larger of like an outlier effect on that mean it's going to have. So we can just compare these values in the table to the mean and see which one's the farthest away. So I already did that off screen. You can see here that I did choice A, choice B, choice C, choice D. Choice D resulted in the largest distance. So that's the answer. So he results in the largest difference. He's going to have the largest outlier effect because he's the farthest away. Conversely, the one with the smallest difference is looking like choice B. So if the question said we wanted the smallest difference, then we would pick choice B. So now, really quick, you don't need to know this to do the question, and you really shouldn't do it this way, but they do test you on this from time to time. I think we could actually go and compute the mean, so I'll go through that really quick. So they told us the mean. Look, I have this equation here, mean equals sum over n. So we've got mean is 3245. So let's write that down. 3245 is equal to the n is, there's 10 numbers in that calculation. The sum is 1800 plus 3100 plus 3500 plus 8600. That is giving me 17,000 plus whatever the sum of all these things is. So why don't I call that question mark? And we can find the sum of all those things if we multiply both sides by 10. Again, guys, you don't need to do this for the question. I'm just trying to help you understand. I'm going to prove to you that what we did works. So 32450, and then I'm taking away 17,000. And the sum of these guys is, solving that equation, I am getting 15,450. Now we can go compute the mean. Again, remembering there's going to be 9 data points after we take away one. And we can see which one has the biggest difference from 3245. So let's go do that. Okay, guys, again, this was not the fastest way to do this question. I'm just helping you review the concept and showing you that D is indeed the answer. So before we add up those 4 numbers with the sum of the 15,450, we divide by 10, and we get 3245. That's the calculation that the problem essentially did, right? Before we came along. Now we're removing A. So we took away the 1800, and we took away the 10 to 9, because there's only 9 data points now. And then we do a similar process for B. We remove the second number, and then we remove the third number and the fourth number. And you can see, guys, that bottom number that we got for removing choice D, 2,650, that is so much farther away from 3245 than the other options. D's got to be the answer. Okay, question 14. So we pull up the reference sheet, which is in the top right, and we see that the area of a rectangle is equal to length times width. So the length they said was 20, and the width they said was 1. So we do 20 times 1, and we get 20. Really the only thing here is that I could see being a trap is if they like switched up the units on you. But I'm not really seeing any issues with that. It says inch, inch, and then square inches. So it seems like all the units agree. So 20 is the answer. Okay, question 15. So it says Ben saved for X weeks. And then at the end, it says Ben saved for 6 weeks. So that's basically just telling us that X is equal to 6. So we're going to make X 6. So 60 times 6 plus 36y equals 720. 60 times 6 is 360. And I'm going to subtract 360 from both sides. I am getting 36y equals 360. And now I can divide both sides by 36. And I get y is equal to 10. Y is the number of weeks Stacy saved. So that is the answer. We could also do this on Desmos, so let's go do that. Okay, so I just typed in the two things they told us, the equation, and then the thing we discovered, that X was 6. I'm going to click where they meet. And how about I label that? And we can see that X is 6, so Ben saved for 6 weeks. And Y is 10, that means Stacy saved for 10 weeks. Okay, question 16. The question describes triangle A, which is an equilateral triangle, and it's got all side lengths at 280. So I already made this picture with all these side lengths and everything. And the question then says that the length of each side of triangle B is double the length of triangle A. Okay, so it sounds like triangle B is bigger. So let me draw a bigger triangle for triangle B. And then we're going to double them. So each one is going to be 280. Double means to multiply by 2. So 280 times 2 is 560. So the side of each side is going to have a length of 560. And that's really it. I guess you could say it's a bit of a similar triangles problem. It's a bit of an equilateral triangles problem. But we didn't really need to super understand that concept too much. We just had to interpret that sentence that we highlighted in yellow very carefully. Okay, question 17. So the question tells us that X equals 5. So we're just going to find all the X's and replace them with 5. So this is indeed just asking us for f of 5. And we'll do 12 over 11 minus 5. 11 minus 5 is 6. 12 divided by 6 is 2. So f of 5 equals 2. We could also do this entirely on Desmos, so let's go do that. Okay, so I typed in these two equations that they gave us, and we can click on the point of intersection, and we can see that when x is equal to 5, f of x, or in other words, y, is equal to 2. A much easier way to do this is to just use function notation. So when you're given the x value, you don't have to graph it. You can use function notation. So watch, I'll just type in f of 5, and it spits out that y value, which is 2. Okay, question 18. Slope-intercept form. I have shorts that go over this. It's y equals mx plus b. And the function is f of x equals 5/11 x. And then you'll notice there's no like b. So when a constant is missing, that's kind of just like an invisible 0. So you could see if when I write it like that, hopefully you can really clearly see the slope is 5/11. And the y-intercept is 0. This question's asking us for the slope, so we're just going to go with 5/11. That's it. Okay, question 19. I go over this in great detail in my Ottocento on linear quadratic systems. I think it's number 23. Definitely go check that out. So I'm looking at this system, and I see that there's one equation that can be easily solved just by doing one step of algebra. So we're going to come over here, and we're going to subtract 9 from both sides. And we get x is equal to 2. And now we can take that and substitute it into the other equation. So we will get y equals 2 squared plus 16 times 2 plus 63. And we get, that's 4. 16 times 2 is 32 plus 63. And now we're going to do 4. 32 plus 63, that is 99. So the solution to this system is 2, 99, and they want the y value, so we are going with 99, which is choice D. We could also do this on Desmos, so let's go do that. Okay, I typed these two equations in, and now I'm just going to see the solution to the system is always where the two colors meet. So I click there, and I label, and we get 2, 99, the same thing. Once again, guys, they asked us for y. Lots of people probably picked A because they read it too fast. They asked you for y, so we put 99. Okay, question 20. I go over this in great detail, guys, on my Autotento number 28 called Literal Equations. Please go check that out. Okay, so it says in terms of, and whatever comes before that is what we want to get by itself. So we want to get y by itself. So really the only thing near the y is this negative 38. So to move it to the other side, we will add 38 to both sides. That's the opposite of subtraction. Negative 38 plus 38 is 0, so this will go away. And we are left with y equals mx plus 38. And hopefully that just looks like one of the choices. And indeed it does. It looks exactly like choice A, which is the answer. Okay, question 21. I call this unit analysis. So basically, when you have an equation, in order for the equation to make sense, all the terms have to have the same units. Like, for example, if I said 2 inches plus 3 miles equals 5 kilometers. Doesn't make any sense, right? But if I said 2 feet plus 3 feet equals 5 feet, that makes perfect sense because all the terms have the same units. So we're going to use the same information here. So what I like to do is I like to focus on what the simplest term is. To me, the easiest one to wrap my head around is that one number there, 1,007. So let's look in the paragraph where they talk about that. It says she earned a total of $1,007. Okay, so that means the units of this term is dollars. And by that logic, the other two terms must also have units of dollars. Otherwise, the equation wouldn't make sense. So the 10C term has units of dollars, and the 23H term has units of dollars. Now we have to break it down a little deeper. They do tell us that H is the hours in her full-time job. So I'm going to write here H is hours. And then similarly, C is also hours, but for something different, right? It's a different context, so pay attention to that. And we need to figure out the 23. So we need to figure out the units the 23 has. So the question is, it's almost like a mini unit conversion problem. What do I multiply hours by to get dollars? Well, the unit you don't want, you're trying to cancel, you should put on the bottom. So I'm going to put hour on the bottom. And then dollars, the unit we want, on the top. So we'll put dollars on the top. And we see the hours would go away and we would get dollars if we multiplied those. So the 23 has units of dollars per hour. And the 10 also has units of dollars per hour. But they're talking about different things. 23 is for the full-time job, I think. That's what H goes with. And then C goes with the part-time job. So we're looking for questions for choices that mention dollars per hour or dollars earned each hour. And I'm not seeing any of that in choice C or D, but I am seeing that here. Earned for each hour, dollars earned for each hour. That's dollars per hour. And this is also dollars per hour. So let's see which one is right. Well, 23 is with H, and H is talking about the full-time job. And I see that here. So I bet you it's choice A. B is talking, it's got the right beginning interpretation, but it's talking about the part-time job, which is not quite right. I'm going to pause the video and write all of the other choices, what they represent, and we'll talk about it. Okay, so choice A was talking about 23. We picked that because they were asking about it. The other choices, B, C, and D. B is talking about 10. That's the dollars per hour at the part-time job. C and D are talking about H and C, respectively. That we didn't really need to do anything. They told us what those were at the question, so you should hopefully be crossing out C and D at the beginning. It probably wouldn't be too bad to do process elimination on this one, but try to picture a harder one where process of elimination would be more challenging. Make sure you understand this unit analysis I was doing off to the side over here. Okay, question 22. This one is asking us about a graph given the equation. All right. Why don't we just go plot it? I mean, you probably want to watch my basic quadratics video, but I think plotting it is going to be way easier. Just so you know, a quicker way to type in pi is you just type in pi. Okay, so and another thing we could do is you see it's only plotting it like to the right. This is just really bad because of my recording setup, guys. You can get it to look nicer on yours. You can even edit the bounds by going through here, but I'm going to show you what I think is an easier way. I talk about that in the Desmos post, how to edit the bounds, but little neat thing we could do here is we could put x is greater than or equal to 0, and it'll just plot the right half. Anyway, so my drawing is terrible, and I don't want to go through and make it look nicer. The point is you can tell it's going up, right? It's starting at 0, and it's going up. So right away, this one, C, is out because he's like going down, and then D is also out because he is going down. So the question is it A or is it B? Well, instead of making the graph look nicer, why don't we just use function notation to our advantage? So I'm going to do like f of, let's say, I don't know, 5. And I am getting about 4,400. Okay, let's look at both of these graphs at 5. So this one is here. That is looking like 1,500. I don't think that is right. Let's check A. So 5 is about 4,500. That is looking really good. That's about what we got. Somewhere around like 4,400. It doesn't have to be perfect. Great. So plotting this one really helped a lot. You can take time to make it look nicer, but you could also just evaluate the function and test a couple points. If they both had this point, I would go plug in another number like 3 or 7 or something, and then use that point to do further process of elimination. Okay, this is the beginning of module 2B, question 1. So you're definitely going to want to check out my Ottocento number 24 on basic exponentials. You'll also want to check out my percents videos, mainly Ottocento number 1 for this one at least. All right, so I know it's a basic exponential because they say it's an exponential, and then they say they're describing the problem as when x increases by 1. That is a basic exponential, a times b to the x. So the y-intercept, or the initial value, the a, is the y value when x equals 0. Well, you'll notice they told us that right here. So we know that a has to be 60 because that is the y-intercept they just told us. Now to find the multiplier, we have to look at this part where it says what's happening to y. Y increases by 10% of its previous value. To do that, we need to do a 10% increase multiplier, which I prefer to just do on the calculator. So to do an increase, we do 1 plus percent over 100. So 1 plus 10 / 100. And I am getting a multiplier of 1.1. So the function is 60 times 1.1 to the x, which is choice A. Okay, question 2. So we're just going to take this point they gave us and plug it in. The y-intercept is the y value when x equals 0, so we could just plug that point in. So we got 5 times 0 plus 3 times y, which is just y, equals negative 27. 5 times 0 is just 0, so that just kind of goes away. And we get 3y equals negative 27. We divide both sides by 3. And we get y equals negative 9, which is the answer. We can also find intercepts very easily on Desmos, so let's go do that. Okay, so I just typed in this equation. To find the y-intercept, we just click on where the graph meets the y-axis, which is right here. And we get the same thing, 0, negative 9. They wanted the y-coordinate, so we put negative 9. Okay, question 3. Definitely check out my Ottocento number 30 on ratios. The video goes over this in great detail. Definitely go watch that. Because these are squares, we could use scale factors to solve it, like we did in Ottocento number 10. But I think just the way this question is phrased, how it mentions the word ratio, I think just using ratios and proportions is going to be a lot easier. So it says the ratio of side length of square A to the side length of square B. Okay, so I'm going to put side A over side of B. Then it says is, which means equal. And then 2 spelled differently, 4. So we're going to put 2 over 4. Now it tells us that square A has a side length of 23 inches. Well, that is in the numerator. So we're going to put 23 on top. And then the bottom side length B, we actually don't know. So why don't I put an X? And now we got this nice proportion, which all I got to do is cross multiply and divide. So cross multiply, like this. Multiply each diagonal. So 2x equals 23 times 4. Not sure what that is. Getting 92. Now I'm going to divide both sides by 2. And I get x equals 46. So the side length of square B is 46. Okay, question 4. I go over this in a bunch of my shorts, guys. Slope-intercept form of a line is y equals mx plus b. M is the slope and b is the y-intercept. The function is f of x equals 5/11 x. And there is no b, but when there's a missing constant, you could just put a 0. So I'm just going to put plus 0. And now we can clearly see that the m, which is the slope, is 5/11. And the b, which is the y-intercept, is 0. The question wants us to find the slope, so we're just going to put 5/11. B is the answer. Okay, question 5. So they gave us this equation, and they told us that the volume of the soil in the mixture is 2 cubic feet. Well, if you read earlier, it says that the volume of soil in the mixture is y. So really important here. They're basically telling us that y is equal to 2. Okay, so we're going to make y 2. So 32x plus 84 times 2 equals 360. 84 times 2 is 168. So we have 32x plus 168 equals 360. Now we're going to subtract 168 from both sides. That is giving me 32x equals 192. Now I divide both sides by 32. And I am getting 6, which actually is what they're asking us for. They're asking us for the volume of the compost, which is, they said, was x. So the answer is 6. We can also do this entirely on Desmos, so let's go do that. Okay, so I just typed in those two equations that we got from the beginning. I click on where the two lines meet, click label, and I can clearly see that 6, 2 is the solution. So we got 6 cubic feet of compost and 2 cubic feet of soil. Okay, question 6. Definitely check out both my ottocentros on percents. They're number 1 and number 26. There's a couple ways to do this one, but I personally prefer when they're giving me this literal translation to just go left to right. So that's what we're going to do. So I first see 120% of. So the first thing that we do is we divide by 100 and then change the of to multiplication. So that's what we do for percent ofs. Then I see an n. So I'm going to write n. And then I see is, which means equals. And then I see 60, so I put 60. 120 divided by 100 is 1.2, so this is 1.2 n equals 60. And now to solve for n, we are going to divide both sides by 1.2. And I get n equals 50, which is choice D. I suppose you could have solved this on Desmos or guess and check. Let's go try that. Okay, so I'm just going to type this equation in, but just instead of n, I'm going to put x. So 120% of is just the percent symbol on your keyboard. X equals 60. And I'm just going to zoom out and see where that is. And I see that we get a solution of 50. We get the same thing, so it seems like we did a good job. Okay, question 7. So to find f of -3, we are just going to take everywhere there's an x and replace it with -3. So the only place in the actual function that has an x is right there. So we're going to put a -3 there. So we've got 4, absolute value -3 minus 3, absolute value minus 13. So now we just do the order of operations. So we got 4, -3 minus 3 is -6. All right, and the absolute value of -6 is 6. And 4 times 6 is 24. 24 minus 13 is 11. So f of -3 is equal to 11, and that is choice C. We can also do this entirely on Desmos, so let's go do that. Okay, so I typed the function in, and now all we're going to do is type in f of -3, and we get the same thing, 11. Okay, question 8. So on Monday, he did 205 seedlings per hour times 1 hour. So that gives us a total of 205 seedlings. And then on Tuesday, he did 205 seedlings per hour, the same rate. Times, but this time he did, let's see, T hours. We're going to do times T, and that gives us 205 T. And now to find Monday and Tuesday, we are going to just add those up. So this function, S, they call it, is equal to 205 plus 205T. So we can put the T term in front. Addition is commutative. And now I'm like, that still doesn't look like any of the choices really, but we could maybe pull out a common factor. They both have a GCF of 205. So I'm going to pull out 205. And we have left 205T divided by 205 is T. And then 205 divided by 205 is 1. So T plus 1. Which is choice D. Okay, question 9. I go over this in great detail, guys, in my Ottocento number 7, special right triangles. Definitely go check that out. We pull up the reference sheet up in the top right corner of the Blue Book app, and hopefully we see that this is looking exactly like the 30, 60, 90 triangle. So now we just need to carefully place the angles where they need to go. So if you see here, across from X is 30 degrees. So we're going to go across from X, and we're going to put a 30. And then across from the X root 3, we have a 60. So across from X root 3, we have a 60. So this guy is 60 degrees. So the angles in this triangle are 30 degrees, 60 degrees, and 90 degrees, as the name suggests. And it says, which of the following is a measure of one of them? Well, the only one that is in this list, that is in the answer choices, is choice B. I suppose you could go and plug in the 19 and get all the side lengths, but it wouldn't have really helped us answer the question. Okay, question 10. I go over this in great detail in my Ottocento number 4 on factoring. This is basically testing us on what's called zero product property. We've got a bunch of stuff multiplied together, and it is equal to 0. So we're going to take these two things and set them equal to 0. So for that first equation, x minus 245 equals 0, I add 245 to both sides. And I get x equals 245. For the second equation, I subtract 246 from both sides. and I get x equals negative 246. The question just says, what is a solution? You don't have to give a particular one. So I'm going to go with 245, though you could put negative 246. Just make sure you just put one of them. Don't try to enter both. We could also do this entirely on Desmos, so let's go do that. Okay, I typed this equation in, so now I'm just going to zoom out and click on the solutions. So we got this one, and we got this one, and you can see got negative 246 and 245. Seems like we did a good job. Okay, question 11. I go over this in great detail, guys, on my Ottocento number 27, mixing problems. Please go watch that. It will make a lot of sense if you do the examples before tackling this one. Okay, so I just wrote down the equations from that video. Basically, the volumes, the total volumes have to add, but also the volumes of the component, in this case, saline, which just means like salt water. So the volumes of the saline also have to add. So the first equation is going to be the total volume. Well, it says that the total volume of the first thing is X, and then the total volume of the second solution is Y. And the volume of the mixture, it says, is 8. So we're going to do X plus Y equals 8. So like the first cup, the second cup, and then when we mix them together. Notice that 35 is between 20 and 40. So like that's, that makes sense. They should be somewhere in between when you mix them. So X plus Y equals 8. And then for the second one, we need to know what those percents are as decimals. They're just like percent ofs. So all you do is divide them by 100. I already did it here with the magic of television. So 0.2, 0.4, and 0.35. So for that first cup, P1 is 0.2 because that's 20%. So 0.2 times V1, which we already said was X, plus P2, which is 0.4, and V2, which is Y. And then the percent in the mixture, which is 0.35, this is 35%. And then the volume of the mixture, which we already talked about, is 8. So we've got these two equations, and we could actually go and solve them, and maybe I will at the end. But let's go and see if that matches any of the choices. Okay, so it's looking like C is the answer. And we don't have to do this, but why don't we go and actually solve it and talk about what the solution means, because that's important. Okay, so I graphed these two equations, and the solution was 2, 6. So X is 2 and Y is 6. So we've got 2 liters total of the first solution. But remember, the saline in that is only 20% of that. So it's 2 liters total in the first solution, but then 0.4 liters is saline, actual like the salt, right? And the other one, we got 6 liters total, but that one was only 40%. So 2.4 liters saline. So again, the first one, the first cup has 6 liters, 2 liters total, and then 0.4 liters saline. And the second cup has 6 liters total and 2.4 liters saline. I hope this helped. Okay, question 12. So this one, it kind of feels like it's a basic exponentials question, but it's kind of really not. You see how there's just like a point listed here, which I wrote off to the side. All it is doing is asking us to interpret that point. So that's really all we need to do is identify the X, identify the Y, and read the question very carefully. So the X is 5. Call that X. And then the Y is 296. If you don't know how to read function notation, it's essentially just like a point, 5, 296. X is the first number. Y is the second number. However, they don't call this function Y. They call the function F. So how about in my shorthand, I'll call the first number X, and I'll call the second number F, because that's the name of the function. You could call it Y, but let's try to make it easier to read the paragraph. Okay, so let's not even look at the choices, and we're going to look at the question, the paragraph very carefully, and we're going to highlight where it talks about X. So I'll use yellow, the same color. So it says X is the number of years after the end of 1959. Okay, so 5 years after end of 1959. So what's 1959 plus 5? That's 1964. And now we're going to look at the second part, where it talks about the function. The function f models the value in dollars of an investment. Okay, so that is the value in dollars for something like this. The investment is worth, and remember that f value is $296. So $296. Now that I have that interpretation, so that I don't get tricked, now I go to the choices and let's see if there's one that sounds like that. Okay, so I think that B is the answer here. It says here that the value of the investment is estimated to be approximately $296 at the end of 1964. All of that is sounding good. Let's go over why some of the other choices are wrong. So for this one, I don't even see the number 296 anywhere. So, I mean, that can't be right. It's got to mention the $296, right? So I don't really see that anywhere. I actually don't really see 296 mentioned in C either. It also says in both of these $5 greater. We don't know that, and we can actually disprove that, I think. And here it says 5 times greater. And here it says increase by approximately every 5 years. The 296 is there, but it's not telling us anything about the rate of change, guys. A point is just like a static moment in time. Let's actually make a little graph on Desmos and kind of see if any of these statements that are off topic are even true. Okay, guys, so I made a table, and a little trick you can do is you can replace y with f of x1, and it'll evaluate it. And we're going from 0 to 5. It actually says through 1974, but let's just do up to 5. I'm going to zoom in, and you can kind of see that. Let's see if any of these things hold any value. It says 1964. So that's about 295.55 will be $5 greater. That's not true. It's like 295, 273 to 275, 295. So that's like 20 something. So that's not right. And then 5 times greater. Well, I don't know, but I have a feeling 273 times 5, that's nowhere near 295 or 296. So that's not right. And then the other one says increase by approximately $296 every 5 years. That's a constant rate of change. That would be like if it's a linear function. This is not a linear function. I mean, it's hard to tell because of the zoom and like my recording setup. But you see, this is exponential, guys. It's curved. It doesn't have a constant rate of change. So really, all of these are wrong. Not only are they not asking you about these things, they're just not true. Okay, question 13. Before we even start this, I think there's a couple choices we can throw out. If you read the problem carefully, you'll see that it says the kind of implies that the lower bound of each resistor is going to be 0 because it says it has to be positive. So that just means it has to be bigger than 0. So do you see how these ones have bigger than 0 in it? These ones at the bottom do not have that. They start at 20. So I'm not super sure, but I have a pretty strong feeling that C and D are out. So I'm just going to cross those off for now. We'll come back to it. Okay, so it says that we've got 7 resistors, and the sum of them is going to give you the total resistance, which they tell you is 110. So that's how I came up with this little equation here. resistance 1 plus resistance 2 plus resistance 3, etc., is equal to 110. So now it later tells us that the total resistance of 3 of them is 90. So I'm going to put a 90 here in place of, how about 5, 6, and 7? It doesn't matter which ones you pick. And that is equal to 110. I can now subtract 90 from both sides. And I see that the sum of the remaining 4 resistors must equal 20. So, what the heck do we do now? Well, we're pretty much between A or B. Basically, we can make any of the resistors as small as we want. We just can't make it 0. It's got to be positive. But you could make it like 0.0001, right? And so what's the biggest it could be? Well, conversely, if I made this guy very, very close, the one resistor, you want to call that one X. If we made him very, very close to the hot 20, right? So maybe like 19.5, and then we made the other ones like 0.1 each, or 19.6, and then we made the other ones 0.1 each, or 19.7, and then we made the other ones 0.1 each. We could make it pretty much as close as we can to that upper bound of 20. So the answer is B. There's a trap in A, and basically that lies with thinking that all of the resistors, the remaining 4 resistors that they talk about here, lots of people probably read this and think, oh, the remaining 4 resistors are all have the same resistance. So like X plus X plus X plus X equals 20. And then you get 4X equals 20. And then X equals 5, right? But unfortunately, the question doesn't say anywhere that the remaining 4 resistors have equal resistance. So you have to think about it more logically and go, wait a minute, well, how big could I make R1? Well, if the sum has to be 20 and all the numbers have to be positive, I definitely can't make it more than 20, right? If I made it 25, I couldn't make one of the other ones -5, like get it back to 20. You can't do that. So they all have to be smaller than 20 and bigger than 0 because, again, it says positive in the question. I hope this helped. Okay, question 14. I go over this in great detail in my Potential number 31 on similarity. Please go watch it. Basically, we've 2 things we got to know. The corresponding angle measures are equal, and the corresponding side lengths are proportional. This question is actually asking us about angle measures, so we don't really care about the ratio of the side lengths. So actually, this sentence here that talks about the ratio of the side lengths, I'm just going to cross out because that has like nothing to do with finding the angle measures. The thing we need to worry about to find angle measures is that the corresponding angle are equal. And you can make a picture if you want, but a really quick way to figure out which angles go together is to like pay attention to the order they show up in the similarity statement. Like A goes with X, B goes with Y, and C goes with Z. So the question is asking us about angle C. So the measure of angle C must be equal to his corresponding guy, which is angle Z. Well, the question told us that Z is equal to 7x plus 25. So that means the measure of angle C must also be 7x plus 25. Okay, question 15. Definitely check out my short on slope formula. So the slope formula is m equals y2 minus y1 over x2 minus x1. These points are just written in function notation. If you want to make it easier, we can write them down using ordered pair form. That is fine. So we got c comma -2, and then we got 5 comma 22, and then they actually tell us that the slope is 4 for line P. So the slope m equals 4. I'll call the first point x1, y1. I'll call the second point x2, y2. And this gives us 4 equals y2 minus y1, 22 minus -2. over x2 minus x1. That's 5 minus c. I'm going to multiply both sides by 5 minus c. And I get 4 times 5 minus c equals 22 minus negative 2. That's 24. And divide both sides by 4. I get 5 minus c equals 6. I'm going to subtract 5 from both sides. I get negative c equals 1. And now I'm going to multiply both sides by negative 1. And I get c is equal to negative 1. But we got to keep going. The question is asking us about this other function, t. So let's do t over here. So we've got 2 points there. We've got those, and the first one is c comma negative 5, but as we just found, it is negative 1 comma negative 5. And the other one is 6 comma 44. And how about I do the same thing? x1, y1, x2, y2. And I will do slope equals y2 minus y1, 44 minus negative 5 over 6 minus negative 1. And I don't need to do any algebra for that. That I can just put in a calculator. I am getting a slope of 7, which is answer choice D. I don't know how much I would have used Desmos on this one. We maybe could have used it to solve that first equation. But we could actually use it to verify that we did it right. So why don't we go try that? Okay, guys. So I used regression to solve that slope formula that we wrote at the beginning. I still got c equals negative 1. Again, might have been faster to just do by hand. Not sure. Could speed things up a little bit, but I think you needed to know that concept in order to figure it out. But once you get that, we could go and start checking stuff using regression. So I got c negative 2. And I want to regress this one, but it's not letting me for some reason. Yeah, it's not storing the c. I don't know why it's not doing that. All right, so I put negative 1 in for c. So I regressed it. That line had a slope of 4. That was the original line, which was y equals 4x plus 2. And now I'm going to check the second line, which is y equals 7x plus 2. So when we made c negative 1, the first one had a slope of 4, and the second one had a slope of 7. Seems like we did a good job. Okay, question 16. This one's very challenging. I highly suggest before even attempting this that you watch my Ottocento number 5 on function translations and my Ottocento number 29 on factor theorem and multiplicity. Let me zoom in a little bit so we can get a better look. Okay, so if you pay close attention, as I talk about in the factor theorem video, if you pay close attention to the end behavior, this is because they're going in different directions. One's going up, one's going down. This is an odd degree polynomial, so this should be an odd degree. But like, for example, it should be like 1, 3, or 5, probably 3 or 5, something like that. You usually don't ask a very high number of polynomials on the SAT. That's definitely not a line. That would be degree 1. Okay, so we're going to go and look and see if there's any choices that aren't odd degree. So I'm just going to quickly, by the way, if there's an exponent missing, you can just slap on like a 1, right? And then you just sum the powers of x. So, so here the degree is 2 plus 2, which is 4. Both of those at the bottom are 4. And as I just talked about, it has to be an even number. So, so C and D are out. So honestly, if I were pressed for time, I'd probably, either start graphing stuff or just try to take a 50-50 guess between A and B, because you'll see if you find the degrees of those, they are both 3, which is a lot more reasonable and possible with that end behavior. So an odd degree can have end behavior like that. So that is looking good. Now we got to look at this really confusing part about the function translation. So I have the expression pulled up for a function translation over here. So I'm going to write it next to it. We got f of x minus k. So you'll see that there is no h, so we're not shifting left or right, so that's good. That's going to make the problem a lot more approachable. But we are shifting up or down by negative k. So negative k is a positive number, they said, so negative k is a negative number. So we're really going k units down. Again, if you're having trouble seeing that, put like a 5 in for k, and you'll be like, oh, minus 5. That means to go 5 down, right? Minus 5. Anyway, so we need to move k units down. But here's the thing, right? What they did was they told us that the graph of the translated function is shown in the xy plane. So what they're saying is, guys, they already shifted it down. So they shifted it down, and they're asking us about f of x, the original function. So we need to do the opposite translation to put it back where it started. It's kind of like if you went down the street to your friend's house, maybe you're going east, and then you go back home, you're going to go west, right? It's just like that. It's just really poorly worded. I know it's annoying, right? So to do the opposite, we are going to do k units up. So there's probably a couple ways to think about this, but I am noticing, right, that right here in both of these, we have a multiplicity of 2. When we have a multiplicity of 2, that means we're going to have a bouncer on the x or y axis. I talk about that in the factor theorem video. It's going to be like something like that. It's going to be like a bump touching the x or y axis. And you see, if we move the function up, so like pretend you're shifting it up with your mind's eye, the only bouncer we're going to potentially get is here. It's going to like push that up so that this part like sits on the y-axis like that. We could maybe get a bouncer from this point over here, but only if we push the function down. And as we talked about, they want us to push it up. We have to like undo the translation, if that makes sense. So it's really that point goes with that factor of x minus a squared or x plus a squared. And you'll notice that is at positive 4. So that x-intercept has to be a positive number. So if we take those factors and find the roots that go with them, we can see which one is correct. So watch, x minus a equals 0. If we add a to both sides, we get x equals a. That gives us an x-intercept of a comma 0. I go over that in the factor theorem video. We can do the same thing with the other factor, x plus a equals 0. That means the factor that goes with that is, we subtract a from both sides and we get negative a comma 0. The question says a is a positive constant. So that means this guy here is positive, and a positive times a negative is negative. So this hump isn't on the negative x values way over there. It's on the positive side. And as a matter of fact, I think it's 4. I'm pretty certain. So the only one that it can be is the one with this root here, a comma 0, because that's going to give us a positive root at that bouncer. So the answer is A. This is a very confusing question. There's a lot of topics going on. Again, I think if you just understood that first part and then took a 50-50 guess, I think that's more than good enough. You could also start graphing things. I actually went through and tried to find what the graph was. It doesn't come out nicely, so I couldn't do a perfect job, but hopefully that'll drive this home. Okay, guys, so I did the best I could to find values of a and b that actually give us the original graph. So here's kind of what happened in summary. So we had this function, and it was completely off screen. They didn't show us this function at all. Then what they did was they moved the function downward and told us, hey, that's what it looks like when we move it down. And they're basically telling us, hey, move it back up. And the only hint in the answer choices that really stood out to me was that squared. We're looking for that bouncer. So we want to move it up to the point where that point near 4 where it turns around, it sits on the x-axis. And this is what helps us realize the answer. So we must have a positive x-intercept. In my graph, about 4. It's not perfect. We must have a positive x-intercept and a factor that goes with that at the multiplicity of 2. So the factor that goes with that root must have a squared attached to it. And the factor that goes with this root, the x-intercept has to be negative, and it must be a multiplicity of 1, power of 1. Let's go look at the tempting trap answer, which is choice B. Okay, first thing that's standing out to me about choice B, by the way, guys, blue is actually the original graph in the problem. So you see there's no way if I move the blue graph up, it's going to take the shape of the red graph. So that's the first problem. But more importantly, the red graph, as we talked about, the multiplicity, the bouncer, the x-intercept with a multiplicity of 2, that's on the completely opposite side of the graph. So this would be if the x-intercept was negative with that factor, but as we saw in the question, it has to be on the positive side because that's where that point is, right? This is where that point is before we moved it. And if we move it up or down, just up, there's no way that point is going to get over to the other side unless we like moved it left or right or did a reflection, which this question didn't mention anything like that. All we did was want to move it back up. So choice B is looking no good. Hopefully this helps clear up what's going on under the hood. Okay, question 17. For this one, there's a Desmos way and a by hand way, and I actually think the Desmos way is a lot better. So let's do the Desmos way first this time. Okay, so we could solve any equation by doing y equals left-hand side and y equals right-hand side. So that's what I did here. So I'm going to zoom out. And these guys don't fully overlap, but you'll see they do overlap a fair bit. So if there's like any continuous overlap, basically that means it's going to have infinitely many solutions. So you have to focus on the keywords here. The question says, what is the least value of x? So we're going to look, so like the least value of x, that's like the leftmost value of x. So we're looking where they overlap, but the leftmost portion of it. And are you guys seeing that like the leftmost portion of where they overlap is kind of like where this fork is? See what I'm saying? So the leftmost value of x is right there at x equals negative 13. So the answer is B. Let's try to make sense of the by hand way now. Okay, so here is how they tackled the by hand solution in the College Board. What they wanted you to do was they wanted you to recognize that the square root of a square is just equal to the absolute value of the number you originally squared. So think about it. It will always work. If you do 5 squared, you get 25. If you do square root of 25, you get 5. That's the number you started with, right? And if you do negative 5 squared, you get 25. If you do square root of 25, you still get 5. So you get the absolute value. You don't get negative 5, but you get the absolute value of negative 5. So this does always work. This property is always true. You maybe learn about this a little bit in Algebra 2. I can't really remember. Anyway, the point is this entire thing over here is equal to the absolute value of x plus 13. So we have the absolute value of x plus 13 equals x plus 13. And this is going to give us I go over this in the short on absolute value equations. What we do is we isolate the absolute value, in other words, get it by itself. And that's what I did here. It's already isolated. We don't have to do anything. And now we're going to basically see if the thing on the right side is negative, 0, or positive. But because there's a variable in it, we don't know if it's negative, 0, or positive. So what we're going to do is we're going to break it up into two equations. So x plus 13 is equal to x plus 13. And then x plus 13 is equal to the negative of what's on the right side. I go over that in the short, guys. So negative x plus 13. Well, x plus 13 equals x plus 13. There's nothing really to do there. That's just the same expression. That has infinitely many solutions, so nothing really to say there. That's probably that overlapping piece that we were looking at before. And now we're going to look at this one. So we do x plus 13 equals negative x minus 13. I'm going to add x to both sides, and I get 2x plus 13 equals negative 13. And I'm going to subtract 13 from both sides, and I get 2x equals negative 26. And now I'm going to divide both sides by x, not by x, by 2. And I get x is equal to negative 13. And that was the answer. I'm going to explain a little bit more why that's the answer. But was that really worth doing it? I feel like graphing was like a lot easier. Anyway, give me 1 second. I'll try to make sense of this. Okay, guys, so this is a little bit outside the scope of the SAT, but I basically, if you didn't know, you can write absolute value functions as piecewise functions. And what the College Board wanted you to realize, I guess, was that it's infinitely many solutions on that right piece, the x plus 13 piece. But then on the negative x plus 13 piece, again, that's this one. So you see that's where it diverges. That's where it like splits away. It only is equal at that negative 13 value. Again, this is like so much work for a question that probably would have took under a minute by graphing. I'd probably just do it that way. Okay, question 18. We have a linear systems question. We should be jumping for joy if this shows up on our test. This is one of the most commonly tested topics. Please, 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 if you haven't already, go watch my Ottocento number 6 on linear systems. It's by far the best and most important video I've ever made. Why are you even watching this one? Go watch that one. Come back later once you're done with that. All right, so first thing we're going to do is we're going to take note that it says infinitely many solutions for linear systems. That means we have the same slope and the same y-intercept. I'm noticing fractions on this one. 55 is divisible by 11, but 36 isn't. So I think this one is going to be a lot easier if we just clear the denominators, which I go over in my clearing denominators video. So I also go over it in that Ottocento number 6. So the least common multiple, the least common denominator, the denominators are 11 and 22. The least common denominator is just 22. So we're going to multiply this whole equation by 22, and that'll make the maths a lot easier. Okay, so 22 divided by 11 is 2, and then we're doing 2 times 36x plus 55. So 2 times 36, so that's 72x plus, what's 2 times 55? 110. And that is equal to 22 divided by 22 is just 1. So that is kx plus 22 times n, which is just 22n. And now we can use same slope, same y-intercept. That's pretty much it. So we're going to do the same slope. So the slope on the left-hand side is 72. The slope on the right-hand side is k. And same means equal. So 72 equals k. Great. So we know what k is. And now we're going to do same y-intercept. Well, the y-intercept on the left side is positive 110. And the y-intercept on the right side is positive 22n. Same, once again, means equal. So we're going to do 110 is equal to 22n. And we divide both sides by 22. And we get n is equal to 5. The question wanted us to find kn, so 72 times 5. And I am getting 360. Now, whenever we do a problem like this, we always type it into Desmos and verify that we did it correctly. So let's go do that. Okay, so we pretend like we don't know anything. We go back to the very beginning of the problem. We type in y equals whatever's on the left-hand side of the original equation. Y equals whatever's on the right-hand side of the original equation. And then we put in our values for the constant. So k was 72, n was 5. And you can see that this blue line is right on top of that red line. That means it has infinitely many solutions. So we did a good job. And we could double check our calculation too. So let me type in kn. And we get 360. Looks good. Okay, question 19. You're definitely going to check out my order chapter number 9 on basic statistics. It goes over every single thing for this question in great detail. I'm going to assume you've already watched that. You can also watch my short called Median of a Chart. That goes over some important stuff for this question about how to find median of a histogram like this question wants us to do. Okay, so basically what's happening is we got this data set in the picture, and then we are going to add an additional weight of 32 pounds. So like kind of off screen here, if I extend this way, maybe 32 is like somewhere over here. There's going to be one data point like right there. So that is what I like to call in the video a small outlier. And we didn't remove it, we added it, right? So when you add a small outlier, the mean, is going to be pulled towards that outlier that you added. So the mean is going to go down. So it's asking us, will the mean go down in Roman numeral 2? And the answer is it will. I don't even need to do any calculation. I know it's going to go down. Now, as I talk about in the video, generally speaking, for the median, we have to check it. So for the median, we're going to use the equation position of median is equal to n plus 1 divided by 2. We're doing this because we don't know if the median is going to stay the same or if it's going to go down, do what the mean does, right? So the n is the number of data points. So let's first look at the original data set, which is just these. And the question actually tells us there's 14. So at the beginning, n is 14. So the position of the median is n plus 1 over 2. And we're going to do 14 plus 1 over 2. So the position of the median is 15 divided by 2, which is 7.5. 7.5 is in between 7 and 8. So we're looking for the 7th and the 8th, and we're going to average them. We don't actually know what the numbers are, so we're going to just kind of do our best and guesstimate what box it's going to be in. I'm just adding the frequencies to the top, make this a little bit easier for you guys to follow. Okay, so now we're going to add to find the 7th number. This is just like I do in the median of a chart short. So 2, that's too small, got to keep going. 2 plus 1, that's 3. That's too small, got to keep going. Okay, 2 plus 1, 3, 2, 5. Okay, too small, got to keep going. Plus 6, that's 11. Okay, so I passed 7 and I passed 8. So the 7th and 8th number are both in here, the 85 to 90. So the median is somewhere in 85 to 90. We don't know exactly what it is, but we know it's somewhere there. Now we're going to do the new scenario with the one off to the side. So that means there's 14 and we added one. So now there's 15. And now we're going to do position of median equals n plus 1 over 2. So that's 15 plus 1, that's 16, divided by 2 is 8. So we're looking for the 8th value. And again, if we go through that process, 1 plus 2 is 3, plus 1 is 4, plus 2 is 6, still too small, plus 6 is 12. So again, we just passed the 8th number in this box. So the median is 85 to 90. And here's the thing, guys. We don't know what the numbers in that 85 to 90 box are because they don't tell us, right? It could be anything. It could be 85, 86, 87. So we don't know if the 7th and 8th number are the same. So we actually don't know if they're equal to or less. But here's the thing, the question is asking must be less. Do we know for a fact that it has to be less? And the answer is no, we don't. So as we talked about, if all those numbers are the same, if all those numbers were like 88, then they would be the same, right? Because the average of 88 and 88 is just 88. So the answer is 2 only, which is B. Just to give you an example, let's say, for example, the 7th number, it's not, but let's say, for example, the 7th number was here and like the 8th number was here, then maybe the medians would be different, because even though we don't know what they are, one's in the 80 to 85 bin and one's in the 85 to 90 bin. But because they were both in the same bin, we just don't know. So we don't know if it's less or equal. So we put an X, just not to say that it's not less than, it's just we're not sure. Again, the key phrasing is must be. Question says must be. We're not certain. Okay, question 20. You're definitely going to want to check out my Ottocento number 13 basic quadratics. You could also look at my quadratics formula sheet, which sums up a lot of the stuff that's in this question. Just go to my free formula sheets video. So this one threw me through a loop, but it's actually not that bad. Just what kind of stinks about it is we're going to be doing a lot of drawing on the graph. And on the digital exam, you can't draw on the graph. So you're going to have to somehow like copy this graph to your paper, which is like really, really annoying. Anyway, so what we're going to do is it says we're going to remove the data point at x equals 0. So we're going to remove the y-intercept. So if you look here, the y-intercept is that point that's way up there, right? So we're going to just put a big X through that. And now what we're going to do is we're going to look at the rest of the points, and they pretty much perfectly form a parabola, and we're going to just draw that. So I'll do that to the best of my ability. So I think it looks something like that. It's just like the curve of best fit. You just try to go through the middle of where they're trending to the best you can. And there's 2 things they want us to notice here. One, you see how the parabola is like shooting up more quickly? It's like steeper. So that means the magnitude of A is going to be bigger. So instead of 0.04, maybe it'll be like 1 or 1.2, some number bigger than 0.04, because it's steeper than this much more flat original graph. So Roman number 1 is true. It is going to be bigger. The A is going to be bigger than it was before. And now C, I go over this in the quadratics video, is the y-intercept. So if we look at the y-intercept of the original, we can very clearly see that the y-intercept of the original is right there. And the y-intercept of the new graph is right here about. And it definitely went down. So it's going to be smaller than whatever it was at the beginning. I guess they said it was 6.56, so it's going to be less than that. So both of these seem right, and we're going to go with choice C as our answer. Okay, question 21. You're definitely going to want to check out my Ottocento number 23 on discriminant and linear quadratic systems. This one isn't too bad to do on the calculator, guys, and we'll do that at the end, but they will ask you student-produced response questions that are way harder to do using Desmos. So you definitely want to understand the by hand method. So go check out that video, Ottocento number 23. All right, so the first step for first of all, I know it's a linear quadratic system because one of these x's is going to end up being squared. So if you got an x squared, that means one of them is quadratic. That means it's quadratic. So this equation is quadratic, and this equation, the top one has no x squared, so that's a line. So that's how I know it's a linear quadratic system, and I know to use this strategy. So the first step, as I go over in that video, is always to substitute for y. So very conveniently in this one, y is just by itself in both of them. So I can just like maybe take this one and sub it in here, and we're basically just going to glue them together. So negative 2 x minus 8 squared equals, what does it say, x minus c. Now I'm going to try to get everything into ax squared plus bx plus c equals 0 form. So I'm going to expand that left-hand side. X minus 8 squared is x squared minus 16x plus 64. And now I'm going to distribute the -2. -2x squared plus 32x minus 128 equals x minus c. And then I'm going to move the x and the c to the other side. So I'm going to subtract x from both sides. And that will be -2x squared plus 31x minus 128 equals -c. And we got to get equal to 0, so we're also going to add the c to the other side. So let's do that. And we should get -2x squared plus 31x minus 128 plus c equals 0. Now I'm going to very carefully identify a, b, and c. Again, ax squared plus bx plus c equals 0, just like I wrote above. So a is -2, b is what's in front of x, so 31. And then c, not the c in the problem, the c in the formula, is the constant term. So anything without an x in it is part of the constant term. So this entire thing, no x, everything without an x is the constant term. So that is our, air quotes, c. So now we're going to use the discriminant. So that's step 3. And we got to go back up to the question for something important here. They said it has 2 distinct real solutions. So I talk about in the discriminant video, when we got 2 real solutions, we are going to do b squared minus 4ac is greater than 0. Okay, so now we put in all the numbers. So b is 31, a is -2, and then c is -128 plus c, and all that is greater than 0. Okay, so let's do some maths here. So 31 squared, that's 961. -4 times -2, that's +8. Notice how I'm breaking this up into smaller steps, guys. I really don't want to do too many steps at once and then make a mistake. Now we're going to do 8 times -128. That's -1024. And then 8 times positive c. That's 8c. All right, hopefully we're in the home stretch. 961 minus 1024 is -63. So I got -63 is plus 8c is greater than 0. I'm going to add 63 to both sides. And I get 8c is greater than 63. And now I'm going to divide both sides by 8. And I get c is greater than 63 over 8. And now we're going to go back and look at the choices. So it doesn't simplify, by the way. So let's go back and look at the choices. So again, the thing they wanted us to realize was c is greater than 63 over 8. Whenever you're doing stuff with inequalities, you might want to write it as a decimal. So like 63 divided by 8 is 7.875. So c is greater than 7.875. And so 3 is not bigger than 7.875, so a is out. 7 is not bigger than 7.875, so he's out. Well, 63/8 is not bigger than 63/8, it's equal to, so he's out. 13 is the only one that's bigger than 7.875, so that's got to be the answer. Now for this one in particular, probably way faster to just do it on the Desmos graphing calculator because we can guess and check since it's multiple choice. So let's go try that. Okay, I typed in the 2 original equations and now I'm just going to guess and check the choices for C. So I put in 3 and the blue and red don't touch at all. So that means they have 0 real solutions. So that's not right. 7, a little bit harder to tell, but still seems like they don't touch at all. 0 real solutions. Let's try 63 over 8. Okay, let's see here. 63 over 8 actually has 1 solution. See how it just touches at 1 point? But that's not right. We want 2 solutions. Let's try 13. Gotta zoom out so I can see it. Okay, this one has 2 real solutions right there and right there. So it seems like we did a good job, definitely on the actual test, doing it this way faster. Okay, question 22. You're probably going to want to watch my Ottocento number, let's see. There's two we need here. We need the one on quadratic formula, and we also need the one on factor theorem. Both of those are like crucial to this question. I think the factor theorem one is 29. So definitely watch both of those. Otherwise, this is going to make like 0 sense. I'm going to actually, this one's long. I'm going to record it in pieces and edit it together. So you might want to pause the video and like write the question down, or take a picture of the question or something. We'll be right back with the first equation. Okay, we're going to solve the first equation. X squared plus 6x plus 4 equals 0. We would love to factor that. But if we factor it, like we need numbers that add to 6 and multiply to 4. That's not possible. Like 2 times 2, that doesn't add to 6. 4 times 1, that doesn't add to 6, adds to 5. So these are going to be irrational solutions. So we should probably either complete the square or quadratic formula. I prefer the quadratic formula. So I got it on the screen here. A is 1, B is 6, and C is positive 4. So we're going to just put those all in. So we got negative 6 plus or minus 6 squared minus 4 times 1 times C, which is 4. And we're going to do over 2 times A. A is just 1. And now we're just going to like evaluate all these like kind of 3 pieces here. So we got X equals negative 6 plus or minus, well, 2 times 1 is 2. And then over here, I've got root 6 squared minus 4 times 1 times 4. I just put that in a calculator and I got 20. Now the next step, as I go over in the quadratic formula video, is to simplify the radical. So we need to simplify root 20. So root 20, the biggest perfect square that goes into it is 4. So we could rewrite it as 4 times 5. We pull out the 4. The square root of 4 is 2. So we get 2 root 5. So we're going to write that over here. X equals negative 6 plus or minus, and instead of root 20, we're going to put 2 root 5 over 2. And now the final step is we are going to split the fraction. So we're going to like go like this, draw a little heart, like that. Negative 6 divided by 2 is negative 3. And 2 root 5 divided by 2 is just root 5. So the solutions are negative 3 plus or minus root 5. And that means one of them is negative 3 minus root 5. That's the smaller one. And then the bigger one is negative 3 plus root 5. And now we're going to go back to the beginning. And they tell us, really important here, R is less than S. So the solution that's smaller is R, and the bigger one is S. So the smaller one, you could put in a calculator if you weren't sure, is negative 3 minus root 5. So that's R. And then the bigger one is negative 3 plus root 5. So that is S. We could also speed this up by solving it on a physical scientific calculator. So let's show that. Okay, so this is just a digital version of a physical calculator that I have on my desk here, just so that you guys can see better. Remember, you're allowed to bring your own calculator to the test. I go over calculator recommendations in some of my other videos. So we're going to go to second polysolve, and then the quadratic equation one. And we're going to enter A, B, and C. So 1, 6, and then 4. And you see it tells me negative 3 plus root 5 and negative 3 minus root 5. So we could have sped this up a lot if we did it that way. Let's go talk about the second equation now. Okay, so now we're going to solve this one in a very similar fashion. So A is 1, B is 10, and C is 5, positive 5. So we got negative 10 plus or minus root 10 squared minus 4 times 1 times 5. And all that is over 2 times 1. Okay, now we start evaluating. So we get negative 10 plus or minus square root of something. I'll come back to that. 2 times 1 is 2. And 10 squared minus 4 times 1 times 5. Just really don't want to mess that up. I'm getting 80. Great. Next step is to simplify the radical. We got to think about root 80. So root 80, let's see, what's the biggest perfect square that goes into 80? I believe the biggest is 16. So we get 16 times 5 is 80. We pull out the square root of 16, and that's 4. So 4 root 5. And now we're going to come back over here and replace it, and hopefully it just comes out nicely again. Remember, guys, it's an SAT question, so it should, right? All right, so we get negative 10 plus or minus 4 root 5 over 2. Now we're going to split the fraction again. So negative 10 divided by 2, then this divided by this. So we get x equals negative 10 divided by 2 is negative 5. And then 4 root 5 divided by 2 is 2 root 5. So that's the solutions to this one. The smaller one will be the one where we subtract that second number, so minus 2 root 5. And then the bigger one will be the one where we add that second number, so plus 2 root 5. And now we just got to read the question. It says here that the two solutions, t is the smaller one, u is the bigger one. So t is negative 5 minus 2 root 5, and u is negative 5 plus 2 root 5. So that's really important. We'll come back to that later. Once again, we could speed this up a lot by using a physical scientific calculator. Let's go do that. Okay, so we're again going to go to second polysolve, quadratic, and then we're going to do A was 1, B was 10, and C was 5. And we get the same thing, negative 5 plus 2 root 5, negative 5 minus 2 root 5. You probably wouldn't believe me with how long this is, but when I did it this way, I did the whole problem in like a minute, minute and a half. So, having a physical calculator that can solve quadratic formula maybe can save you some time on some questions. Okay, let's go back and find the answer. Okay, now we're going to take everything that we learned and find the solutions for that third equation, which are r plus u and s plus t. So r plus u is going to be this one and this one added together. Okay, so negative 3 plus negative 5, that's negative 8. And then negative root 5 plus 2 root 5, negative 1 plus 2 is positive 1. So that's positive root 5. And now we're going to do s plus t. And we are going to add these two. Negative 3 plus negative 5 is once again negative 8. And positive root 5 plus negative 2 root 5. So 1 minus 2 is negative 1. So this is going to be minus root 5. Oh, that's pretty nice. These two numbers are conjugates. So now we're going to take these roots and use the factor theorem to write the factors for the quadratic that goes with this. Okay, so factor theorem tells us that if we have a root, the factor that goes with that root is x minus the root. I go over that in the factor theorem video. You could also just use factored form of a quadratic, which is pretty much what I have written here. I just didn't use s and t like on my formula sheets because I didn't want to confuse you with the s and t in the problem. A, they actually already told us a is 1. You see that's right there. A is 1 in that equation. So we don't need to worry about that. So we just need to write these two horrible factors. So we got x minus, and then always put parentheses. We've got the first root, which is negative 8 minus root 5. And then x minus the second root, which is negative 8 plus root 5. And there's a way to do this using like a difference of squares trick. I am just going to do it using distribution. I'll go over the trick when I'm done, okay? I just think personally it's easier to just do distribution. So we're going to do x, and then look, I'm going to distribute this negative to these two guys. So x minus negative 8, that's x plus 8. And then minus negative root 5, that's plus root 5. And then we got x again plus 8, and then minus times positive root 5, that's minus root 5. And now we're going to distribute these two trinomials. So we look here and we go like this, bop, 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 and we get x squared plus 8x minus root 5x. And now we take the second term and go bop, 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 and we get plus 8x plus 8 times 8 is 64, minus 8 root 5. Okay. And now we do the third one. Pop, pop, pop. And we get plus root 5x plus 8 root 5. And then root 5 times minus root 5. That is minus 5. So we now can just combine all the like terms and the answer will become clear. So the minus root 5x and the plus root 5x, those cancel out. That just goes to 0. The negative 8 root 5 and the positive 8 root 5, those just cancel out. Those go to 0. And we get x squared. 8x plus 8x is 16x. And then 64 minus 5, that is 59. So this is the quadratic that goes with that problem. And we can look and hold up the equation they gave us. And they're asking us, what is C? Well, C is just 59. And that is the answer. I'm going to go over a slightly faster way that's a little bit harder to understand for this part. And then maybe we'll talk about Desmos. See you in the next part. Okay, so a little bit of pattern awareness could potentially save you some time on this. They talk about this in the College Board explanation. I don't know, I figured it was worth spending like 30 seconds on. So basically, if you're really keen-eyed, you'll notice that, wait a minute, I don't need to distribute this whole thing. The constant term is always equal to the part of the distribution that, just have the numbers in it. So those last two numbers, so like this thing here times this thing here is going to be equal to the constant because that's where all the numbers are, right? Think about it. If you did a simpler one like x plus 2 times x plus 3, you would get expand that out and you get a constant term of 6. 2 times 3 is 6. It's kind of the same thing here. Negative 8 minus root 5 and negative 8 plus root 5 are just messier numbers. Anyway, so when we multiply them together, we'll get C. When we multiply them together, the negative signs cancel, so we don't need to worry about those. That's why I didn't write them down here. The negative signs will just go away. Negative times negative is just 1. And now you can see that if we multiply these two together, this resembles the right half of the difference of two squares formula. And we could see that this whole thing is equal to a squared minus b squared. Well, if we look here, we see that a in this formula is negative 8. So we do negative 8 squared minus, and then b is root 5. So we do root 5 squared. And that gives us 64 minus 5, which is 59. So you could have skipped some of the distribution. I think you might be able to get the answer using Desmos 2, and maybe that would be even faster. So let's go over that now. Okay, so I did kind of solve this using Desmos. If you would like this Desmos graph, just ask in the comments, and I'll link it if YouTube lets me. First thing I did, I plotted the first equation, I found the two solutions, and then I just copy pasted them and made the smaller one R and the bigger one S. All right, and then we came here and did the second equation, made the smaller one T and the bigger one U. These are not exact values, which is annoying, but it's better than nothing. And then we found the solutions by doing R plus U and S plus T, like the question said. And then I plotted the factored form. This is the quadratic equation that they're asking about. And A is equal to 1. Remember, they said that. And they're asking for C, which is the y-intercept. And a really quick way, you could zoom out and click on it. It's like up here. Or you could use f of 0. So that's what I did because I think that's easier. F of 0. And again, 58.999. If you put that, that would be wrong. Remember, when we were doing all these calculations at the beginning, this is rounded by Desmos, so we need to round it to offset Desmos's rounding. So the answer isn't actually 58. It's really 59. Again, even if you weren't certain it was 59, that would have been way better than just guessing or not knowing what to do if you didn't know any of the concepts I went over previously. I hope this helped.